So remember, your exam is tomorrow. You have all of these multiple choice numerical response questions. If you do finish them at some point between now and the exam, then you also have textbook problems you can be working on. You also, pretty much anything in chapter 7 and 8 in your textbook is fair game. You also have, and just to refresh my memory, did I make available the extra practice handout last week? I put it up here and said you could pick it up. No? Okay, I didn't think I did, but part of my brain said I did. But I made some copies anyway, so that's good. There's this extra practice handout here that covers chapters 7 and 8 as well. You can pick that up if you require additional help. Plus, there's that whole slew of problems at the end of your unit handout. Okay, but in the meantime, we're going to spend some time going through multiple choice numerical response questions here, and then I will talk with you about the written response. So, any questions? Go ahead, Jason. 6? So we're talking here about comparing the domain of a function y equals log base 4 of x to the domains of those other functions. And we want to know which of those other functions has a different domain. It's kind of like one of these things is not like the other. When you take a look at your knowledge of y equals log base 4 of x, you should have by now, much in the same way that you know y equals x squared is a parabola with its vertex at the origin, much as you know that sine of x starts at the origin and goes up and down, you should have a visual in your brain that there is a vertical asymptote on the y-axis, and log base 4 of x goes through 1 on the x-axis. That's y equals log base 4 of x. The curviness of it, or the steepness, or the shallowness of the curve is dependent on the base. So y equals log base 2 of x would, not that it really matters for this question, I don't think y equals log base 2 of x might look like that, whereas y equals log base 10 of x might look like that. Okay, I got those backwards. The top one is, yeah, the first one I drew would be a higher base. It would be more extreme. Anyway, I guess what I'm getting at here, everybody, is that you should know the domain here without even really sketching this, is that x is greater than or equal to 0. You should know that. And when you take a look at all of these functions given a, b, c, and d, Jason, they are all in some way transformations of that graph that we have in our head that I've just drawn. And the only way I can move that asymptote and therefore change the domain is to shift this graph either to the left or to the right. So if I multiply x by 2, what I'm doing is introducing a b value of 2, which means in choice A, things are stretched horizontally by a factor of a half. That's not going to move the asymptote. It's going to end up looking something like that, but the domain will still be correct. When I take a look at C, again, there's a tendency for you to want to group that x and the negative 2 together, but it's not that way. It's log base 4 of x and then minus 2. That means that C would be this graph shifted down 2, which still has that domain. I mean, I could just answer the question by talking about B, but I'm going to do this instead. So this is a shift of 2 units down. This would be a vertical stretch by a factor of 2 because we've multiplied the function by 2, which would mean that this point would be invariant, but everything above would be further above and everything below would be further below. same domain. The idea here, though, is that for B, which is the correct answer, this has a h value of -2, which means this shifts the graph 2 units to the left. And although I've made a mess with all those other graphs, it's going to take that original graph along with the asymptote and change the position. Does that help? Other questions? Go ahead, JV. 17? I think it's pretty clear, I hope it's pretty clear, that when you go from this function to this function, that we introduce a value of the parameter of A of -1. We're multiplying a function by -1, and this goes back to day 2 probably, or maybe day 3 of the semester. We know what happens to get from, and I'm not sure why I put negative on both. We know what happens when you go from a function to the negative of the function by multiplying it by -1. It's a vertical reflection. And once again, and as we learn about more and more functions, and we'll continue to do so in the next unit, we're going to discover more and more often it's the case that you can arrive at a goal, at a destination, like y equals -2 log, like y equals negative log base 2 of x. You can arrive there from y equals log base 2 of x using different series of transformations. There's other ways to get there. And what I want to point out to you before we even look at the choices is there a different way that we can write y equals -1 log base 2 of x? Well, the only thing you can do in terms of logarithmic rules is you can move that coefficient of -1 up top and write it as an exponent of the argument, which means this goal, this destination, is the same as this destination. It's the same as y equals log base 2 of x to the -1, which when you look at it, it doesn't appear as though it's a transformation, because when you go from the original function to this one that I've written, which is the same as negative log base 2 of x, all we've done is we've introduced an exponent on the argument. But from grade 10 math, a negative exponent means a reciprocal. So this can be written as log base 2 of 1 over x. So any of these three functions that I've written on the left are vertical reflections of the original function. And I thought for a while we would be able to explain it in terms of a different series of transformations, but that idea, I guess, doesn't really apply. I take it that one of your choices is y equals log base 2 of 1 over x. I would go so far as to say to you that rather than giving this question the way it is given, I think it's fair that I could cut this sentence from the question. That would maybe elevate it to a diploma exam question. If you're told it's reflected across the x-axis, you shouldn't need to be told that it's -1 times log base 2 of x. You should know that. And from there, you can move that exponent up. I would probably, if I were to give this question, I think I could make this into a really good exam question by saying to you, we reflect that original function in the x-axis. Which of the following two functions would be the new function. And I could have choice A, y equals log base 2 of negative x, and y equals negative log base 2 of x. I could have choice B, y equals negative log base 2 of x, and y equals log base 2 of 1 over x, and I could do it that way. Anyway, JV, does that make sense? Okay. Other questions? Go ahead. Of course. 18. So we are asked, and this is a bit of a devious question because you're given a equation of a function, but it's not in terms of y, so you can't really put it into your calculator. We always, in our calculator, we can only graph functions, which means you have to rearrange for y. Well, let's rearrange that for y. By the way, these all appear to be logarithmic functions, don't they? They all appear to have a vertical asymptote on the x-axis. Well, let's take that original function, which is 4 to the negative 2y equals x. And translate it into a language that's going to be helpful for us. If we want to rearrange this for y, then we should rewrite this in exponential, or sorry, I guess in logarithmic form, because it's in exponential form. This would be written as the base 4 logarithm of x is equal to negative 2y, and now we're getting somewhere. Now I can rearrange this for y and say y is equal to negative 1/2 multiplied by log base 4 of x. I'm dividing by negative 2, so rather than just write over negative 2, I think it would be better to write negative 1 over 2. Now we're not going to graph this on our calculator, because as soon as you can graph this on your calculator. But remember that your graphing calculator does a horrible job graphing logarithmic functions. And two, if you get too reliant on just going, I'm going to enter it into my calculator, sooner or later somebody in Edmonton is going to come up with a diploma exam question that I've never thought of before that you just can't do that way. Or it might be a written response question where you have to explain. So maybe you have a written response question where you're given this equation of the function as x equals y, 4 to the negative 2y, and you're asked to first of all rewrite it in logarithmic form and graph the function by discussing translations or transformations of the basic logarithmic function. There's ways that it could be done. When you take a look at this, we can imagine that this is a transformation of y equals log base 4 of x. So if we know what y equals log base 4 of x looks like, we know what this looks like. It's going to be a vertical reflection and a stretch vertically by a factor of 1/2. Does that make sense, Ben? So what does y equals log base 4 of x look like? Well, it has an asymptote on the y-axis. It goes through the x-axis at 1. That's y equals log base 4 of x. So I need to reflect that and stretch it vertically by a factor of 1/2, which means everything is going to get half as close to the x-axis. If I were to do that stretch first, it's going to land roughly here. If I reflect it, it's going to look something like that. So now you're going back to your choices and you're looking for something, well, it's A. Does that make sense? Okay. Other questions? Eight? This is, well, it's really the same idea as whatever question JV had asked about. I forget the number. You're going from y equals, it's kind of the same, but it's not exactly the same. You're going from y equals b to the x and you're transforming it to y equals 1 over b to the x, but 1 over b is b raised to an exponent of negative 1. So we have b to the negative 1 to the x, which can be written as b to the negative x, because when we have, it's called the power of a power rule, when you have a power raised to an additional exponent, you multiply the two exponents. And now when you compare y equals b to the x to y equals b to the negative x, you've introduced the parameter of what we would call in Unit 1 b, the coefficient of x. But when I say that b here is negative 1, I'm not talking about the base. I'm talking about your a, b, h, k set of parameters. And if b is negative 1, in other words, if you multiply x by negative 1, what you're doing is you're reflecting horizontally across the y-axis, and the equation of the y-axis is x equals 0. When you take a look at your axes, the y-axis, this thing right here, everywhere on that y-axis, x is 0. X is 1 here, x is 2 here, x is 3 here. Anywhere along this line, x is negative 1, x is negative 2. So everywhere on that line, x is 0. So the answer would be C. Other questions? Go ahead, Zebi. 32. I'm not sure if you did this problem. Did you do this problem and you got the incorrect answer? Did you get an answer that was there? You didn't. Okay. So anytime we have an application of exponential growth or decay, you're going to use this formula from your formula sheet, which is y equals a times b to the t over p, where your variables are y and t. So if you translate this equation into a graph, the graph is always a representation of y growing or declining over time. The other letters in that equation, a, b, and p, are parameters. They define the growth or decay. They define the question. A is always the initial amount, which means in this particular case, we start off with 148 grams of something. You're told in this question, and I've talked with you, everybody, about this before, you may not be told the meaning of half-life on a Math 30 diploma exam. So you do actually kind of need to know that half-life is how long it takes for 1/2 of the substance to be remaining or to decay. And what that means in half-life problems is that P is the half-life. Did anybody do this question and get the wrong answer, but you got an answer that was there? I know at least one person did because we talked about it. And I'm pretty sure I know what happened here, but P is the half-life. P is what we're after. The question is, what's the half-life? And when you take a look at the rest of the question, I guess we should put B in here. B is 0.5 because it's being multiplied by 1/2 regularly, because that's the way physics works with radioactive decay. The problem is that you're trying to find one of these parameters, so your equation is y equals 148 times B, which is 0.5, raised to the t over p, and you're missing p. And when you're missing a parameter, the strategy that I've given you from maybe lesson 1 or 2 of this course is that you put in an ordered pair. That's how you solve this problem. And we're told that there's 5.2 grams left, after 3 days. So there's your ordered pair that you're going to put in. Now there's a bit of a problem because the answers are all in hours, but we'll get to that in a bit. When you put those numbers in, you're going to have 5.2 equals 148 multiplied by 0.5 to the 3 over p. And I know that when people solve this problem, this is a difficult problem, first of all, but I know when most Math 30 students solve this problem, they end up putting the 3 on the bottom and solving for t instead. It's just what you're used to seeing. So this is the equation that we have to solve. I'm going to go through and solve this. I have to divide by 148 first, and rather than me worry about what 5.2 over 148 is, I'm just going to say 5.2 over 148 is 5.2 over 148. It's a number, okay? This is going to be equal to 0.5 to the 3 over p. The only way that I can gain access to that unknown of p is to take the logarithm of both sides. Is that okay to that step, Zebby? Okay. So when I take the logarithm of both sides, I will have the logarithm of 5.2 over 148 equals the logarithm of 0.5 raised to the 3 over p. I had to resist the urge there because I just wanted to write the 3 over p out in front. And I think if you were just doing work on a multiple choice or numerical response question, you would do that. But, you know, if it were a written response, you'd want to show this in steps. I can bring this 3 over p down, so I have log of this number, 5.2 over 148, equals 3 over p. This is my power rule for logarithms, times the logarithm of 0.5. I guess I don't really need the brackets, but that's okay. Be very careful. I'm going to actually rewrite this as 3 log 0.5 over p. The thing you're trying to find is in the denominator, so be careful when you're cross-multiplying and solving. And this is log of 5.2 over 148. So when you cross-multiply or multiply both sides by p, however you want to think of it, you have p log of 5.2 over 148. There should be no decimal in that 148 equals 3 log 0.5. And that means that you have to take 3 log 0.5 and divide by log of that number. So let's finish this one to its conclusion, because we do have to talk about the fact that we're going to get a p in hours. And all of your choices are in, we're going to get a p in days, and all of your choices are in hours. Oh, I got a lot of stuff open. There it is. So we're going to take 3 log 0.5, and we have to divide by the logarithm of the quotient of 5.2 over 148. So I'm getting 0.6 something. Now, that 0.6 something, since I put the time in days, that 0.6 something is 0.6 something days. All of your choices are in hours, so if we multiply this by 24, because there's 24 hours in a day, we'll get the answer. Now, we could have put 72 in for t. You could have taken that 3 days and converted it to hours first. Anyway, we multiply that by 2.4. I'm guessing it's going to be about 14.9 hours. Okay. Does that do it for you? That's good? I want to just briefly show you something. I looked through your review problems. I was sure there was a problem there somewhere, but it might be in the extra practice handouts. I'm not sure. When you have this equation and you build the equation, it's safe to say that I should be able to ask you, given the right information, to determine the value of y. So I might give you some information about compound interest, like our example in class, and say how much money is in the account after 12 years. I think it's safe to say that based on the question I just gave you, I can give you a problem where there's enough information, except you need to find p. We have definitely looked at problems where it's exponential growth or decay, and you're asked how long does it take to happen. So asking you to find t is reasonable. I don't know that you've encountered a problem yet where you have to find a, but it's a pretty basic thing. If I told you that you had bacteria that are doubling every, 6 minutes, and I said after 18 minutes there are 100,000, I think it's safe to say you should be able to figure out how many bacteria you started off with. It's really not a difficult thing. Your formula is y equals a times 2 to the t over 6. Just let that percolate in your brain for a minute. You're missing a parameter of a, and yet you're told that when t is 18, y is 100,000, so you put that ordered pair in here. The fact that 18 is divisible by 6 is maybe a mistake on my part in choosing numbers like that. It doesn't have to be divisible by 6. It could have chosen 105. 105 divisible by 6? No, I don't think so. Anyway, you would take 100,000 divided by 2 cubed. It wouldn't be a difficult task, okay? But the one that is related to a question that I was sure is someplace in your review, but I just can't see it, is finding b. So I'm going to make up an example just to show you how that would work. Let's say that in 1975 I bought a mint condition Mad magazine for $2. And in 2021 it's valued at $1,480. Kept it under plastic, kept it in perfect condition. And the question is, what is the average annual percentage growth in the value of that magazine? And just like the question that was returned to you this morning, assignment number 4, I think, where you have population growth rate, that percentage growth or decline is buried somehow inside of the base of the exponential function. So you would take a look at this, y equals a times b to the t over p. You would say, well, a is $2. I don't know what b is. That's going to be the problem. And p is 1. And the reason why p is 1 is because it talks about annual growth rate. It doesn't talk about daily or monthly. It talks about what's the average percent growth every year. And we can drop that 1. So what we are left with is y equals 2 times b to the t. And the ordered pair is 46 years for t. I'm going from 1975 to 2021, which is, I think, 46 years. Comma, let's say 1248, 1480. And I want to go through the solution to this because there's two layers to the solution. And the first one is just what are we going to do to get b? So you put in 1480 equals 2 times b to the 46. So how do you get b? Well, we can divide both sides by 2. That's probably what most people would do. And then you're left with this. And I would like everybody to think on that for a minute. How do we get b? Hand up, then down if you think you know how to get b. And I'm going to give you guys a couple of minutes. And for those of you that didn't put your hand up and down, when you do think you have a strategy, put your hand up and down so I can keep track of things. I didn't divide by 2. Thank you. 740? It's not 1480, it's 740 because we divided by 2. Thank you, Jason. I think it wouldn't be a mistake, but I think some of you might be wanting to take the logarithm of both sides. I don't think you want to do that because you take the logarithm of both sides to move an exponent down on the working line if the exponent contains your variable. Does anybody want to volunteer a strategy that would be very, very quick to just get the value of b? Farhad? So you use your graphing calculator? Okay. Could do that. But algebraically, because you never know, it could be a written response question. Well, what if this were a simpler problem? I mean, this is fundamentally, just look at the structure of this equation. Some number equals an unknown base raised to some number. What if it were 140 equals b cubed? What would you do to get b? You'd take the cube root, wouldn't you? So we have to take not the 146th, we have to take the 46th root of that number. Now, just before I go on here, if you take a look at the cube root, a cube root of something is the same as raising it to the third. And at this level, I think that's a really good way to look at things, is you're going to raise this to a third, you're going to raise this to a third, and that eliminates the exponent of 3, doesn't it? Because 3 times a third is 1. The reason why I say that is, you don't have very easy access to a 46th root function on your calculator. It's a clunky method on your calculator. So we're just going to take the 46th root of both sides by raising both sides to the 1 over 46. And this will give us the value of b. The 46th root is this number. If you wanted to take the 46th root without using the concept of exponents, then you would, again, it's a very clunky method. You enter 46, you go to your math menu and choose the xth root. It looks like garbage. It looks like 46 is a coefficient, and it's not. It's the index. It's in that little crook in the root, and then you would enter 740. Anyway, b is 1.15. So I asked for the average annual percentage growth. And I would say that this is the most popular answer that people would record on a numerical response question. They would enter 1.15. That is not the average annual percentage growth. What is? 15.4%. Yeah, it's 15.4. We have to work backwards. When you're told that population A grows by 9%, you create a base of 1.09. Or you say, well, 100% plus 9% is 109%. And then I divide by 100. So what this represents is B is actually equal to 115.4. Was it 0.4, Jason? 0.4%. And we know from experience that when you talk about growth, the 100% is the thing that's growing. The extra stuff is the stuff that's added on, and it's the growth. So your growth rate, if you subtract now 115.4% minus 100%, this is where Jason's getting the 15.4%. Anyway, I want to show that to you because your exam is tomorrow, and I was sure I had it in that handout that I created, but it's not there. So go ahead, Sienna. Absolutely. You said 34? Oh, yeah. Well, this is a complicated question. It's not complicated if you know what to do, but if you've never seen it before, it is quite complicated. Just a little background here. When you talk about earthquakes, very often in news reports you will hear something like the earthquake had a magnitude 8 on the Richter scale. And I will just let you know, generally speaking, how the Richter scale works, although we don't need this specifically for this question. When you go up 1 on the Richter scale, the earthquake becomes 10 times as bad. So if I had an earthquake of magnitude 5 and I had an earthquake of magnitude 7, the magnitude 7 earthquake is actually 100 times greater. Okay, it has to do, it's called a logarithmic scale. Now there is a formula we can use to calculate the actual intensity of the earthquake, which is how much the ground shakes, if we know the magnitude on the Richter scale. So I here is the intensity. And M is the magnitude on the Richter scale. You might, I better back up. Intensity is the thing that tells us something about what's really happening, how much the ground is shaking. So you might say, why invent a new scale? Why not just talk about intensity? Because when you go from magnitude 1 to magnitude 9, it's 100 million times more intense. So the numbers get very big. Okay. You're also told that this is a reference intensity, which is kind of a bizarre thing to say, but it's just some number. It's like in physics, Sienna, we might have just a constant of proportionality, just some extra constant in the equation that it doesn't matter which situation we apply the equation to, you're going to use that number. It's the same for everything. So what are you told? You are told that there is a weak earthquake. We're not going to use this table. I just put that there to tell you what these things stand for, I and M. And there is a strong earthquake. And the magnitude of the strong earthquake is 5.3. And that's pretty much all you're told, except you are told the intensity of the strong over the intensity of the weak is 125. So we've got all these things floating around because the strong earthquake is 125 times more intense. So what we are going to do is use this equation up top and write out a statement for the intensity of the strong earthquake and write out a statement for the intensity of the weak earthquake and see where it leads us. So the intensity of the strong earthquake is equal to the reference intensity times 10 raised to its magnitude. and the intensity of the weak earthquake is equal to the reference intensity times 10 raised to its magnitude. And this seems like a horrific set of equations for us to work with, because we're trying to find this, and there's so much else we don't know. But if we divide both sides of this equation, if we divide both equations, on the left side we're going to get IS over IW, and on the right hand side we're going to get 10 to the 5.3 over 10 to the m. Again, Sienna, on the left-hand side, we got IS over IW, but IS over IW is 125. So forgetting about exactly how we're going to accomplish this, there's an equation that all of a sudden everything has disappeared except for m, and we can solve it. There are lots of ways for you to solve this equation. I might choose to rewrite this as 10 to the m equals 10 to the 5.3 over 125. So what I've done is I've located the term or the piece that has my unknown, 10 to the m, and I've cross-multiplied to move it onto the main line. And then I suppose we can take the log of both sides. Sienna, are you okay with me just moving the m in front in one fell swoop? Okay, so then we have m log 10 equals log of 10.5, 10 to the 5.3 over 125. This is equal to 1. I mean, you could take log of 10 to the 5.3 over 125 and divide by log 10, but log 10 is 1. So that will be our answer. It's, this is one of those questions that I include in the review just in case it's on a diploma exam. And I hate earthquake questions. I really don't like them. I think they're a little too... They're just put on exams to kind of bring the marks down a little bit, to be honest. I don't think there's anything really of value. Maybe that's wrong. It's a nice application, but it's a weird one. Other questions? $39? So the equation m multiplied by log base p of n is equal to q can be rewritten in exponential form as what? Remember, well, not remember, I'm sure I've told you this, but you can only convert logarithmic to exponential if you have a logarithm equal to something. You cannot convert into a logarithm, into an exponential form from logarithmic if there's anything else there. Like if I had that, you cannot just in one roll of the dice get an exponential form out of that. You would have to isolate the logarithm first. And I've combined logarithmic with exponential here. It really doesn't matter. If you want to make it even simpler, I guess I'm missing an argument. We'll put an X in there. If you want to make it simpler, you could have something like that. But my point stands that you have to have a logarithm equal to something, and we don't have that here, Zebi, because of that m. But what we can do is write this as log base p of n equals q over m. And now we have the logarithm equal to something. I'm really saying specifically you need a coefficient of 1. That means I can write this as p to the q over m equals n. Now, is that a choice? B. Be careful, though, because dividing both sides by m is not the only way to get a 1 in front of that logarithm. What I could have said is I could have said from the original question, I went like this, I could have done the following. I could have taken that coefficient and raised it as an exponent on the argument, in which case I could write p to the q equals n to the m. Those are both legitimately exponential forms of the original logarithmic equation. Does that make sense? Okay. Other questions? $45? At the end of this, I'm going to give you a neat little rule. Okay? First of all, and this is a weird question, could you do this on your calculator? Yes. I would say that you would never see this as a written response. You know, one of these is correct, and I would never see it as a written response. You would never see it. Show how to go from log base 1/5 of 1 over x to, the answer is D, isn't it? Is the answer D? Okay, I know that because I know this added little rule. You would never be asked to show that. So let's tackle it from a standpoint of your calculator first. I have log base 1/5, which, you know, because we're going to be working on our calculator, I'm just going to write that as 0.2 of x. What I'm going to do, this is a cheaty kind of method, is I'm going to evaluate what that is for an obscure value of x. Meaning I don't want to choose 2 for x or 1 for x. I want to choose something like x equals 1.8. So when I use x equals 1.8, I'm going to have log base 0.2 of 1.8. Most of you would probably use your log base function. I'm going to use the change of base formula and take the log of 1.8 divided by the log of 0.2, and I get negative 0.36. It's very easy to lose yourself in all of a sudden why is it negative. It's negative because the base is so small. That's maybe the way to look at it. But it's unimportant. What did I say? Negative 0.365. Approximately. We'll recognize that number again. So now what I'm going to do is I'm going to evaluate each of these with that same 1.8 for x and see if I get that number. This method is a good strategy as long as you're recognizing that you choose some number for x that's not a really common number. You don't want to end up getting the same answer by a fluke. So, you know, I'll pick on C. If I take the base 10 logarithm of 5 times 1.8, I don't get that number. If I go to D, if I take that was 1 over x, wasn't it? I'm going to have to fix that. This is 1 over x. I didn't write that down, nor did I do it. So let me repeat that. This would be log of 1 divided by 1.8 divided by log of 0.2. You get positive. Okay? And there's a reason you get the positive of it. So you get positive 0.365. I apologize for that, Zebby. So now we can do C again. Well, I already did C, right? It didn't work. If I do D, I'm going to have log of 1.8 divided by log of 0.2. And I get, man, I'm just having a hard time this morning. Log of 1.8 divided by log of 5. Forgot brackets. Third time's a charm. Log of 1.8 close brackets divided by log of 5 close brackets. Doesn't matter about that. You get the same number. Okay. Now, I'll give you the rule here first before I delve into how it can work algebraically. If you had, and it's interesting because we've talked about this a little bit earlier, if you had the following, log base, I'll just go with base 5 of 1 over x. It's got nothing really directly to do with this question. I can write this as log base 5 of x to the negative 1. Which means I can write this as negative 1 log base 5 of x. These are the same. Here's a little shortcut rule. If you ever want to take the argument and flip it over, all you have to do is change the sign on the logarithm. So if I had negative 3 log base 8 of 1 over a, that's equal to 3 log base 8 of a. I am allowed to do that. Because ultimately this negative can go up here as an exponent on that argument, and that negative 1 flips the argument over. Okay? On the other hand, if we had, and I'll go away from the 5s here, log base 1/3 of x equals something. All right? And you're not going to do this every time. I'm going to give you the rule and you will learn from it. I could write that in exponential form as 1/3 raised to the a equals x. I could write the 1/3 as 3 to the negative 1. And that means that I could write this as 3 to the negative a equals x. And now I'm going to go back into logarithmic form. And when I go back into logarithmic form, I end up with log base 3 of x equals negative a. I mean, look at those two. Those two are the same. They're the same. What happened was the base of the logarithm got flipped over and the logarithm switched signs. Because, let's face it, everybody, whether I put the negative over with the a or I put the negative with the logarithm, it doesn't matter. So between these two rules, the one on the left and the one on the right, it says if you take the argument and you flip it over, the logarithm switches signs. If you take the base and flip it over, the logarithm switches signs, which is why I knew that D was right. Because if I flip the base over, it becomes 5, and that changes it to a negative logarithm. But if I flip the argument over, it becomes x, and that changes the negative logarithm back to a positive. So if you flip both the base and the argument, you're allowed to do that. You're allowed to flip both the base and the argument. Does that make sense, Evie? Okay. Other questions? Yeah. 48? Okay, so we have to solve this for a. The problem with logarithms goes back to the thing that we had to deal with trig, which is there's so many masks that a trigonometric expression can carry with it. There's so many different appearances it can take on, even though it's the same thing under the mask. If we want to rearrange this for a, my very first thought is that I'm going to write this in exponential form. And I purposefully covered up the answers because I suspect I know what's going to happen. If we convert this to exponential form, which is 27 to the b equals 81a, and divide both sides by 81, I suspect that this is not a choice. Am I right? Okay. Now, I know sometimes it's nice to look at the choices to try to figure out what's going on, but let's avoid that in this question. can we simplify 27 raised to the b over 81? Well, 27 can be written in base 3, and so can 81. And that's, I don't know how to put it other than to say, it's nice if you can recognize that. If I write 27 to the b in base 3, that's 3 to the 3 to the b. 81 to the 3 is 3 to the 4. And I can write this as 3 to the 3b over 3 to the 4. And then we have a common base in which we can subtract the exponents. And I suspect that 3 raised to the 3b minus 4 might be a choice. It might not be, because there's other ways that you can write this. But it is. It's b. Let's talk exam. Is that okay? Let's talk exam survival here. You know, let's face it, you're studying for an exam that's on logs and exponents for tomorrow. You're going to be preparing for a diploma exam that contains everything, so you might forget more stuff. So you go, well, how can I possibly figure out which one of these is correct? Here's a unique method of kind of cheating the system here. Choose a value of a and calculate b according to this equation. And don't choose a as 1. Don't do that. Choose a equals, I like to keep the number small, 1.2. Let's use 1.2. So I'm going to take the base 27 logarithm of 81 times 1.2. And many of you would use the log base function. I know that. I have to use the change of base function, so I'm going to take the log of 81 times 1.2 and divide by the log of 27. So let me write that down so you can see what I'm doing. I'm putting 1.2 in for a to calculate b, and I'm using the change of base formula, so it's log of the argument over log of 27. And make sure I got my brackets right on this one. I get 1.39. You get the same thing, those of you that tried it? Okay, so you get about 1.388. All of these other ones are a in terms of b. Well, we just calculated b, so if I put b here in choice a, and I get 1.2 for parameter a, then choice a is right. Now, because this is a whole bunch of decimals, you might be wise to store this in your calculator someplace. And I know that if you have a TI-84, you can go up and continue to grab it, but I'm going to store it, and actually I'm going to store that as b because it's actually b that we've just found. So I'm going to put it into choice A. Log of 81 divided by brackets b that we found, log of 27. Well, I don't get 1.2. I don't get 1.2, so that's not right. If I look at choice B, and I take 3 raised to, in brackets, 3 times the b value I found minus 4, I get 1.2. So it's kind of a unique way that you could do it. Other questions? Go ahead. 47? This seems like, well, at first glance, it looks very confusing, doesn't it? There's a lot going on here. It's a very busy statement. A raised to the 5x equals log base c of, and this is all in brackets. I'm going to add another set of brackets, c to the a raised to the 3x plus 8. And the first thing that I'm going to do will probably turn the light bulb on for most people. I'm going to rewrite this as a to the 5x equals a to the 3x plus 8. And just before I get to why I did that, can you solve this? Well, yeah. base a equals base a, the exponents must be equal. Why was I allowed to do that? Well, the base c logarithm of c to the a is saying, to what do you raise c to get c to the a? It's a. This was one of the very first things that we talked about, one of the very first examples when we were doing logarithms, is that this is equal to a. Now, by the way, many of you, myself included, see that it's a not by saying what I just said. What I just said is log base c of c to the a is the exponent to which you raise c to get c to the a, which means it's a. I know it's a because I can move that a in front, and I know log base c of c is 1. Because c to the 1 gives you c. And then you're left with a. Anyway, now what you would do here, Liam, is you would just write 5x is equal to 3x plus 8. Subtract 2x from both sides, or 3x from both sides, get 2x equals 8, so x equals 4. Good? Other questions? Go ahead. Okay. So, again, there's a couple of different ways you could go about a question like this. I suppose what we could do is use a system of equations approach. It's not really an equation. We're just asked to find out what log base 2 of w is. But we can write this log base 2 of w, which is what we want to find, as log base 2 of 16 to the m times 8 to the 2m minus 1. This is what we want to find. What is this saying? It's saying, what exponent do you raise 2 to what do you raise to get 16 to the m times 8 to the 2m minus 1? So I'm going to write it into exponential form, even though there's no other side to this equation, because it isn't an equation, it's just an expression. I'm going to say 2 raised to our answer is going to be 16 to the m multiplied by 8 to the 2m minus 1. Why am I saying 2 to the answer? Because this logarithm, which is what we want to find, is the exponent to which you raise 2 to get that mess of stuff. And now what we're really dealing with here is an exponential equation, really. You're trying to find the value of that exponent. And since 16 and 8 can both be written in base 2, I can write all of these in base 2 and compare the exponents. Uh, 16 is 2 to the 4. Zebby, are you okay with me just writing 2 to the 4m? Okay, and again, you might want to, on a written response, write 2 to the 4 in brackets raised to the m. This is 2 to the 3 times 2m minus 1. I don't want to multiply that 3 through for the group of students, because I know that some of you will be wondering where I get 6x minus 3 from. Okay. But ultimately, this is 6x minus 3. And everybody, since we're multiplying common base expressions, we're going to add the exponents. So you're going to get 2 raised to the 4m plus 6m minus 3. My x came out of left field. It should be an m, of course. So it's 2 to the 10m minus 3, which means 10m minus 3 is the exponent to which you raise 2 to get 16 to the m times 8 to the 2m minus 1. Good. Is there a way to cheat the system here? Well, yeah. You pick a value for m, 1.5. Figure out what w is equal to. Take the base 2 logarithm, whatever you get. And then, since the base 2 logarithm is what we're trying to find, put your original m into one of these and see if you get the same thing as the log base 2 of w. Farhan, did you have your hand up?
Yeah, for
45. 45? Okay. 46? Okay. So we want to know what this is equivalent to. There are a couple of options here. One of the options is we could take this logarithm, log base x of y cubed z, and tear it apart into separate logarithms. And I'm going to do that first. The only reason why I'm considering that is I see over here there's one where we've got separate logarithms everywhere, right? So maybe this is how we're getting our answer. The first logarithm would be log base x of y cubed plus log base x of z. The second is log base x of y plus log base x of z squared. Of course, you'd better put a set of brackets around that. Make sense? So if I were to remove the brackets and swing my exponents down in front, this is definitely a case where I'm keeping my eye on one of the choices. I'm really suspicious that this is the correct answer because I see a 3 log y. Now, I don't know if it is or not, but we're going to continue and find out. Then we have plus our log base x of z. Then I have minus log base x of y. And I have minus 2 log base x of z. Oh, so close. But close may count in horseshoes and hand grenades, but it doesn't count in math. Okay? I can really see why somebody would choose C. In fact, somebody might look at the original question and go, well, that's definitely C. But because we have to subtract both of those logarithms, and in case it isn't obvious, this is the problem, right? Okay. So it's not, yeah.
Would you be able to use the logarithmic law to put that in quotient form for the expression?
Put it into exponential, you mean?
No, since you're subtracting each other.
Oh, you said quotient. Yeah, and that's my next move. So I started off by saying it's possible that maybe the correct answer is arrived at by tearing apart all of the logarithms. But it's also possible, since we have 2 logarithms, that we can put it together. And since we're subtracting, what Ben is saying is, let's go back to the original question and let's write this as a single logarithm with the quotient law. The difference of logarithms is equal to the single logarithm of the quotient. So this is what I have, and I can simplify that argument. I have y cubed on the top, I have y to the 1 on the bottom, which will, when I cancel a y, give me y squared. And then I have z squared on the bottom and z on the top. When I cancel a z from the top and the bottom, I have z on the bottom. So the correct answer here is B. Yeah.
What if you were to just factor the log from the original question? Could you do that?
No. And this is, no. I want to talk about that. This is an idea that everybody has at some point in time that is an impossible thing to do. It's not possible to do what you just said. Let me give you a different illustration, though. Can I factor root out of that? But yeah, that doesn't even make sense, right? What I'm saying is, can I write this as root of x minus 3? Well, you can't factor out an operation. An operation is a function. You can't factor out a function unless it's a function of something. So when we go back to this and you look at the top, and I know this is less obvious, there's a tendency maybe to do this. I'm going to factor out log base x. You can't. But if you did, you wouldn't even have something that approaches the right answer anyway. It's just going from here to here is not a possibility. You can never factor out a function. It's like factoring sine out of something. You can factor a sine of x out, but not a sine. Go ahead, Jason. 9? Okay. Have a great day, Mr. Hetlinger. Okay, what is the x-intercept of a function? So we have y is equal to log base a of x minus d. A x-intercept is always found by choosing y equals 0. So ultimately we have to put 0 in for y and solve this equation for x. I can write this as a to the 0 equals x minus d, because that's the equivalent exponential form of log base a of x minus d equals 0. A to the 0 is equal to 1. So now we have 1 equals x minus d, which means x equals 1 plus d. There's a way that you could have found the x-intercept there by translations, because log base a of x has an x-intercept of 1. When we have x minus d, you're shifting it d units to the right, which would mean it would be 1 plus d. Okay. I hope that was helpful this morning. Just a couple of minutes left, but I don't think time to really go over any other questions. Briefly, your written response would be solving equations. And I want to say to you here that you need to know how to solve an equation that's exponential by making it a common base. You need to know how to solve an exponential equation by taking the log of both sides, because you can't use a common base. And you need to be able to solve basic logarithmic equations, where you either get log equals log and drop the logs, or you get log equals non-log and write it in exponential form. Don't forget, with logarithmic equations, you always have to check for extraneous roots, because you're not allowed to take the logarithm of anything that's negative, and you're not allowed to take the logarithm of 0 as well. The argument for a logarithm has to be positive. I hope that was helpful this morning. I feel as though I'm a little off my game this morning for some reason. Got lots of sleep. Maybe I got too much sleep. Anyway, we'll start the exam about 5 minutes or so into the seminar tomorrow. When the bell rings, have a great day, and we'll see you later.